Okay, so today what we're going to do is we're going to sum it all up and look at the last process or detail of working with networks. Okay? This is the thing that will allow you to make decisions about a network. And what we're going to be talking about are something called spanning trees. We took a brief look at trees earlier, right? When we were looking for the shortest path. But when we did that, what we did was we just looked at every possible link, right, to get from point A to point B, and then we added them up and then found the shortest one. Well, that's not the most efficient way of finding the shortest or longest path. Notice it says minimum or maximum. So sometimes you want the longest path instead of the shortest path, depending on what kind of information you're given. So we're going to talk today about how to create what's called a minimum or maximum spanning tree. And it's really simple, but you have to stay focused and know what it is that you're looking at. Okay? So what we're going to be doing is we're going to be using the numbers from the edges, right, in your network to be able to come up with either the shortest route or the longest route. Minimum or maximum amount of values. So you're going to be using those values in numerical order. And again, the order you use is going to depend on, are you looking for a minimum or a maximum? So let's just go to the book and we'll talk about this. So remember that a spanning tree is going to form connections to every node. That's important. Not just some of them. You're talking about every single node that's there. So you need every value from every edge to be included in your spanning tree, right? Unless there's a shorter path to get to it, or it's already been included. And again, we're going to be looking at how to do this and look at several examples. It's really good. So you don't want to have to represent. So you don't have to represent every path or every edge, but it has to hit every what? Node. Okay? So that doesn't mean that every path, every edge is going to be used, but you will have to make sure you include every node. Okay? So it does not have to be a path or a circuit. In other words, we're not concerned with making a full circle, hitting every node. We're not concerned with a specific path through every node. So we don't worry about is it traversable or not. All we're doing is looking at every single node and a way to get there. And again, it does not need to use every edge. So your notes need to include that a spanning tree forms connections to every what? Node. Does not have to be a path or a circuit. And it does not have to use what? Every edge. Remember, the lines that connect the nodes are called edges, yeah? Okay? All right. So a minimum spanning tree connects all the nodes using the minimum weighting of the edges, and there can be more than one minimum for a spanning tree. So you can get the same value going two different ways. So two different directions, you go the same number, travel the same number of miles, etc., or something. Okay? And you can also have times when they want the maximum. So you're just going to be doing exactly the opposite. So minimum is one way, maximum is the other. So if you look at some examples, they want to connect the electric sockets in the house. Well, if you're going to do that, you want to use the minimum amount of wire possible, right? To minimize the cost. Okay? Or to connect a series of towns with the shortest length of road. So you're going to pave the road. You want the shortest amount that you can possibly get. Yeah? So let's look at the steps for making that work for us. Your first step, and this should go in your notes, guys, is to make an ordered list of all the path links. Okay? Now, it looks as if they're saying do every single path there, every single edge. But that's not really true. If you've already got a path to point B from point A, then you don't need a second one. Right? So remember that there were sometimes two ways to get to a particular spot, so you don't need a second one. Okay? But each node needs to be connected. And they need to be in order. For a minimum, it's always smallest to largest. If you want a maximum value, you'll go largest to smallest. Okay? So the order of the numbers, so in this particular case, 15, 16, 17, 18, notice they're all in order, numerical order, from smallest to largest. And that's what they mean by ordered. Okay? All right. Got that? Okay. Step 2. Highlight any paths that lead to nodes with a value of 1. You must use these. Now, value of 1 sounds a little odd because value, you might think, but that's the number on the edge. It's not that. You might replace that with the word degree, because that's what we've been calling it. A degree of 1 means that only one path goes to that particular node, right? So only one edge goes to the node. Those have to be used no matter what. Okay? Because that node has to be reached and there's only one way to get to it, right? So it's only one way to do that. Okay? So we use the word degree, value, same difference. So let's look at this one. Highlight any paths that lead to a node of 1. You must use these. So if you look at this, there's only one way here to get to node F, right? So that value of 22 kilometers has to be used. So they've highlighted it. Okay?
Why is it crossed out?
We'll see in a second. Okay? Yeah, they've jumped ahead a little bit. But that's okay. No, not you. They have. I don't know why they've crossed it out first. But anyway, so you're going to cross off values as you use them in a minute. And that's what they're doing. They know you need that one, so they went ahead and highlighted it and crossed it off because we know we have to put that one on our list. So as they put them on the list, they're crossing them off so they don't use them again. And that's why it's crossed out. You'll see it in the next step. Okay? Yeah, they shouldn't have done it there. Okay. Right? Then you're going to highlight the shortest pass on your network, crossing off each one as you go. So they've included every single value here. You can do that, and it's fine. You're going to be picking the ones you're going to use, but because you're not going to repeat any of the longer ones anyway, so you can just leave them off. But so you can put them all on your chart if you don't see it. If it makes it easier for you, just put them all on there. But you don't really need them all if you can see that you already have one going to one. Sometimes the network is going to be small enough that you can already see I'm going to F to G with using this short path. I don't need to put the longer one on there, right? But if you want to put them all on just in case, that's fine. Especially if it's information like yesterday we talked about information from a chart. It's really easy just to list everything from the chart, okay? But make sure they're in order. So we're just going to highlight the shortest paths on your network, crossing off each one as you go. So the first number that I have, the smallest number I have is 15. And 15 is this little thing from B to C. So you'll highlight it so that you do not need another path that connects B to C. Does that make sense? And since I used that one, I'm going to cross it off my list. Okay? What's the next shortest number? Smallest number, 16. And that's between what? Here you go. So I highlight that so that I know that I've used it, right? Cross it off. The next one is 17. Where's 17? Between A and E, right? Cross it off. Next one is 18. And I'm just going to keep doing this until I've reached every node. And then I know that that's the smallest values that I can use to reach every node. Okay? So 18 is from A to B. Okay? But do you notice that you've already really connected A to B? You went through another node to get there, but are they not connected? Is there not a highlighted route from A to B? Then that means I don't need to use that one. Right? We're not going to put on anything that we don't need. And I don't need a second route to A to B. I can get through C. And because those were the smallest values in my chart, even though it's not the shortest distance from A to B, it's still one of the shortest distances to complete the entire thing. We don't want to put any roots on there that we don't need. Does that make sense? So any roots that you already have, any nodes that you already have connected, you don't want to reconnect them with another path. Okay. Also remember, we already had that one drawn out too, because we have to have that one no matter what, because it's the only path that goes there. So 19. 19 connects A to D. Do I already have a connection to A to D? No, I don't, right? So I need to connect A to D. Now, there was another connection to A to D, the 20, but I don't want to use that because 19 is smaller, right? We're looking for the minimum numbers we can use. So there we have 20. What does 20 connect? E to D, right? Okay. But can I already get to E to D on a highlighted path? Yep. So I don't need 20. 22 I've already used, right? 23 connects C to D. But are C and D already connected by a highlighted path? Yes. So do you see it's not about connecting every single node using every edge. We're only going to use enough edges to connect all the nodes. Do you see that right now I don't have to worry about 23 and 30? Why? They're all connected to something. So do you see the highlighting is already connected every single one of them? And that's your goal. Now I know the minimum routes to get to every single node. Okay. Now, is it the shortest path between each node? Nope. But it's the minimum to get to all the nodes. Okay? And that was our goal here, was to get to all the nodes. Okay? So you'll see they've highlighted the same thing I did, that B to C, there and there and there and there. And they've stopped there, don't need any more. Okay? No point in using 18 because A and B are already connected with highlighting. Even though going through C is not the shortest route to B, we still have a route to B, right? So this is the shortest connection from D to the rest of the spanning tree is right there, the 19. Again, we just go in order. You're always going to find them. And then the last step is to calculate the total length of the roads needed to collect all of the towns. So what I would do is I wouldn't mark off things that I used like they did. Instead, I would circle the stuff I used. Because those are the ones you're going to have to use. Oh, sorry, they didn't do the 19. Because those are the numbers you're going to add up to get the minimum length. Okay? So the shortest way to get to every single node is by using those particular edges or those particular pathways. Okay?
Sorry.
All right. So the length of the total thing is simply add up the ones you used. And so you would need 89 kilometers of roads to reach every node. Make sense? Now, what if I wanted the maximum distance? Yeah, simply reverse the process and use the 30 first, and then use all the larger numbers first. Okay? So be careful about do they want the minimum spanning tree or a maximum spanning tree? For minimum, you always start with the smallest number and go to the what? Largest. For a maximum, you'd start with the largest number and go to the smallest. Okay? And in any branch or any node that only has one edge going to it has to be included no matter what, because it's the only way to get to that one. So always find those first. Okay? So let's do an example. Highlight the minimum spanning tree for each diagram. Give its value with units. So here we have a diagram that shows the distances between the towns. They've already started the chart for you. You will always make this chart. Okay? Now, you don't need every single value, but if you want to just put every value in numerical order, that's fine. One thing you can do is simply start them, or you can find them. So 5, we used 5 already, right? So I have the 5 on the 5 kilometers there. 6 occurs twice, so it needs to occur twice in your chart. Okay? There's no 7, so the next number is going to be 8. There's no 9, 10, or 11, so the next number is going to be 12. Then 13. Then no 14, but there is a 15. And then finally, there's an 18. All right? So all I did was go through and find every single value from my network. Now what we'll do is we'll use those values to find the minimum spanning tree. So Are there any of the nodes that only have one edge going to it in this particular diagram? No. This one has a degree of 4, that one 3, that one 3, that one 4, that one 2, right? So there's none that have just one edge going to it. So we're not concerned with, we don't have any that we have to use, right? Which means that we'll just start with the smallest one. The smallest number is 5, and that connects these two. Okay? The next number is 6, and there are 2 with 6, so we need, but they connect different ones, so we'll use them both. Right? So we use both 6s. Have I connected every node yet? Not yet. There's still this one to get to, right? Okay? So think about where you're headed. So the next number is 8, but 8 connects this one and this one, but what do you notice? Aren't they already on a highlighted route? So in other words, they're already connected. So I don't need the 8. Then the next one is 12. 12 connects these two, which I do need because it's not connected to the rest of them yet, is it? So I did use the 12. Are all the nodes now connected by some route? Yep. So do I need the other numbers? No. So my minimum spanning tree is 5 plus 6 plus 6 plus 12. We're simply going to add those together. So it gives us 24, 29. And they are in what kind of units? And if you don't put the units on, your answer is completely wrong. Okay? So the minimum value that we can use, the length of the minimum spanning tree is 29 kilometers. All right? All you have to do is make sure you've got every number included in your chart. Make sure that you're looking for a maximum or minimum, and then make sure that you are connecting every single node. Okay? Excellent. Okay. Look at number 2. What do you notice? Hey.
Pinterest, why you lie?
I was at the orthodontist.
One with a degree of 1, yeah. So it's single pathway. You betcha. So let's just get all our numbers in there. We have a 3, but what else do you notice?
There's 3.
There's another 3. Oh, there's another 3. So again, all we're doing is going through and finding the minimum values. Right? There's a 4. Any other 4s?
No.
Nope. There's a 5. Any more?
Yes.
Yep. So 2 5s. Is there 6?
Yes.
2 of them. Any 7s? 2 7s. 8.
Yes.
And a 9.
Yeah.
Yeah. Gotta love the enthusiasm.
Spanning tree is 18.
Okay? Stop that. All right. Now, let's start by seeing, are there any edges that are any nodes that have only one edge leading to them?
Yes.
Yes. That one right there. She's so excited. Okay? So that one has to be included no matter what. Okay? Then, so let's highlight that one and then start looking for the minimums on the others. So remember, any one of them. So if that had been the 9 one, we'd still have to use it, even though it's a big value. Okay? So the next one is a 3, another 3. Well, here's a 3 going there, right? So I need to use it. Here's a 3 going there, and that's connecting 2 nodes that aren't already connected, so that means I need to use it. Okay? Then the 4 is right here. That node is not connected, so I know I need to use the 4. Then we get to 5. Well, there's a 5 there. It's connecting this node and that node. Are they already connected?
Yeah.
No. So I need to use the 5. Now, could I have used this 5 instead? Yes. Doesn't matter. But don't use both. Okay? Well, no, because we use 3 3s, right? But the reason I'm only choosing one of them is because if I connect using this one, then I don't need the other one. Do you see that this node is now connected to this node? Okay. If I did it the other way around, that's perfectly fine. Because this node is connected to this node, right?
So you can do it either way.
You can do either way. Yeah, there can be more than one way. But it's still only going to give you 1 5. Because I only used one of them. You can use one or the other, but not both. There's no reason to use both. Because they were connecting new nodes each time. So if you have something that's not connecting a new node, that's when you won't use it. Okay? Now, is every node connected? Yes. So I can stop and add them together, and I get what?
15, is it? Wait, no.
18.
Oh, it's
Wait, how do you tell whether they're all connected?
Well, you see all the dots have a line going to them? So you're highlighting as you go.
But not. Oh, all the nodes have things.
All the nodes, all those dots have a line going to them, right? Have a highlighted section. And that's how you know when you stop.
At least one going on.
At least one, yeah. Okay? It may be a long way to get there, but it's still, they're all connected. So 18 what?
18 minutes.
Minutes. You leave off those units, I'm counting it wrong. Aren't you happy? Okay? All right. It's all right.
I spelled minuets.
Minuets. So 18 minuets to get there. All right. So let's look at the page numbers then for your homework. So your homework, pages 45 through 49. There'll be some minimum ones and some maximum ones. Okay? There you go.